Hi, welcome to this lesson on Analytical Geometry, Tangents to Circles, Part 2. Let's have a look at question 6. The circle with center P, 4, 4 has a tangent AB at the point B, and the equation of AB is given by y minus x plus 2 equals 0. We're also told that A lies on the y-axis, and we want to determine the equation of the line PB. Okay, so PB is this line here, which is the radius line. Okay, so first of all, if I rearrange this equation, I'm going to get y equals x minus 2. And that tells me a lot, because it tells me the coordinates of A, the y-intercept, is 0, negative 2. And it tells me the coordinates of the x-intercept, which will be 2, 0. Okay, if I substitute x equals 2, I'll get y equals 0. So now we want to find the equation of line PB. So recall that PB is a radius line. So the gradient of the line PB times the gradient of the line AB must be negative 1, and that is because the radius is perpendicular to the tangent. So therefore, the gradient of the line AB is just 1. So I get MPB times 1 equals negative 1. So therefore, the gradient of the line PB is just negative 1. And that makes sense. It's a negative facing straight line from left to right. So far for the line PB, I got yPB equals negative x plus c. So now I need a point on this line PB, and I've got the line point P44. So I can substitute that point, P44, and I get 4 equals negative 4 plus c. So if I add 4 to both sides, I get c equals 8. So therefore, I get y equals negative x plus 8 as the equation of PB. And again, that makes sense. If you extended this line upwards, you'll see it'll cut the y-axis at a positive value. Okay, so that is the equation of line PB. Determine the coordinates of B. So now B essentially is the point of intersection of the line PB and AB. So we can set those two straight line equations equal to each other. So we have negative x plus 8, that was this green line, and that must be equal to x minus 2, that is the red line. So if I solve for x now, if I add x to both sides, 8 equals 2x minus 2. Then if I add 2 to both sides, I get 2x equals 10. Dividing both sides by 2, I get x equals 5. Okay, and that makes sense. You can see the x-coordinate is slightly bigger than this x-coordinate of 4. So it's 5. And I can substitute into any of these equations. So by substituting into x minus 2, 5 minus 2 is 3. Okay, so that is the coordinate of B, 5, 3. So we can put that in there. Determine the equation of the circle. So already, because it's a non-origin center, I already know that it's going to be x minus 4 all squared plus y minus 4 all squared, because it's the opposite sign of the center, equals r squared. Now r is the radius, but we can form a right angled triangle here. So from 4 to 5 it's 1 unit, and from 3 to 4 it is 1 unit as well. So for finding r squared is going to be 1 squared plus 1 squared, which is 2. So therefore the equation of this circle is x minus 4 all squared plus y minus 4 all squared equals r squared, which is 2. Okay, and if you substitute the point B, 5, 3 in here, you're going to get 5 minus 4, which is 1 squared, and then 3 minus 4, which is negative 1 squared. Added those two together, you'll still get 2. So this is definitely a point on the circle. Okay, so that's the equation of the circle. Okay, so let's just put the point in here. Describe in words how the circle must be shifted so that P is at the origin. Okay, so here's P44. So in words, you would need to shift your entire circle to the left by 4 units. Then you'll end up here at 0, 4. And then you need to shift your circle down 4 units again, and you would have your origin here at 0, 0. So in words, so we say that we must shift the entire circle by 4 units to the left. So you have a magnitude and a direction, and then shift down by 4 units. Okay, and then that'll give you the circle, the same circle with the circle with the same radius length. In this case, the same radius root 2. okay, because r squared was 2, but it'll have a new origin point, 0, 0, a new center point, the origin. Okay, if the length of PB, so again, this was 5, 3, if the length of PB is tripled and the circle is shifted 2 units to the right and then 1 unit up, determine the equation of the new circle. Okay, so let's see what's happening first of all geometrically. The length of PB is tripled. So remember the length here was root 2. So if I triple that length in all directions, okay, I'm going to get a bigger circle that looks something like this. Okay, it still has the same center, 4, 4, but now the new radius is 3 root 2. That's the new radius. Call it capital R. Okay, now after you've done that, you now take that big circle and you shift it 2 units to the right. So now it's going to end up in something like this. So it's going to go a bit out of the page, but that's fine. So it's there now. Okay, and then you want to move it 1 unit up. So in this blue graph here now, you take the pink one and you move it 1 up. So it's going to look something like that. Okay, so all we need to keep track of is where the center is going. We already know the new radius. Let's call it capital R. It is triple the old radius, 3 root 2. Okay. But now the center is changing, so let's keep track of how the center changes. So initially you have P, which is 4, 4. Then it goes to a new center, let's call it P prime. And that means you shifted it 2 units to the right. So now it's going to goes to 6, 4. Okay, 4 plus 2 is 6. Then that new one, P prime, is shifted 1 unit upwards. So on the Y values, it's going to go to 5. So there's your new center point now. So therefore, the equation of the new circle is going to be x minus 6 all squared plus y plus 5, not plus 5, rather minus 5, because it's the opposite sign, all squared equals, now this is your new radius. So your new radius squared is going to be 3 squared is 9, root 2 squared is just 2, so it's 18. And that is the equation of your new circle based on those transformations. So you have to keep the transformations in that order. Otherwise, it might adjust certain things. Okay, so we tripled PB first. We got the new radius length. Then we shifted the circle 2 units to the right and then 1 unit up. Out of interest, the old equation circle was x minus 4 squared plus y minus 4 squared equals... what was it, 2. So look what happened. For this one here, it went from minus 4 to minus 6, and then it went from minus 4 to minus 5, and then it went from 2 to 18. So you can see how rapid of a change it is by just adjusting the parameters in such a way. And lastly, we're given a equation of a circle with center A, as this equation here, and then another circle with center B given by this equation here. We are asked to prove that the two circles touch each other. Okay, so let's go ahead. So I'm going to work with the easier circle first. 5x squared plus 5y squared equals 25. Now, if I divide both sides by 5, I'm going to get x squared plus y squared equals 5. Now, that is a circle with the center origin and a radius of 5 units. Okay, so that's important. Then I'm going to look at the next one, which is the more complicated one. X squared plus y squared plus 5 equals 16x plus 8y minus 30. I'm definitely going to have to do completing the square here and get it into a general form. So I'm going to bring all the x and y terms to the left. So I'm going to get x squared minus 16x plus y squared minus 8y. And then I'm going to move the positive 5 over to get negative 35 on the right. So let's complete the square. For here, it's going to be x squared minus 16x. Half of negative 16 is negative 8. Square negative 8, you get plus 64. Then immediately subtract 64. Okay. Or you could just add 64 on the right-hand side. It's the same process. Plus. Then you get y squared minus 8y. Now that negative 8, half it is negative 4 and square it is 16. Then you need to subtract 16 immediately, and then it's negative 35 on the right. So this will factorize nicely into x minus 8 all squared. Okay, and then this will factorize nicely into y minus 4 all squared. And then you have minus 64 minus 16, that is minus minus 80, right? Yes. Because negative 60 and negative 10 is negative 70, and a negative 10 is negative 80. Okay, so now you have x minus 8 all squared plus y minus 4 all squared. And if I add 80 to there, that should give me 45. Okay, and that is your r squared value here. So therefore, if r squared is 45, then r is the root of 45, which is the root of 9 times 5, which is 3 root 5. Okay, so that's the radius length, 3 root 5. Now, negative 8, negative 4, that center point is then 8, 4. 8, 4 is going to be somewhere up here. Okay. And now we want to prove that the circles touch each other. So essentially, if I look at the radius now of C, let me just adjust this so that it's going to hopefully be in line here. So there's the point C now. It was given as 8, 4. So if I draw the circle, the goal is to see that it only touches at one point. Okay, so how do I know if it actually touches at one point? Well, remember what we said when we looked at the properties of circles. We saw that the distance between the two centers, let's call it D, if that is equal to radius 1 plus radius 2, then we know that the two circles only just touch each other at one point. So first of all, this is 3 root 5, and that is 5. Okay, so R1 plus R2 is going to be 5 plus 3 root 5, if we did our calculations correctly. Yeah. Okay, 9 times 5 is 45. Yeah. Okay, so now how do I work out the distance between the origin point O and the point C? So again, I can use distance formula or a right angle triangle. From 0 to 8 is 8 units. From 0 to 4 is 4 units. Okay, so therefore in this right angle triangle, I'm going to have 8 and 4. Something doesn't look like it's adding up here, but let's just carry on and see if we've made a mistake. So this length OC here, which is the distance D, so D squared is equal to 8 squared, 64 plus 4 squared, which is 16. And that's going to give you 64 plus 16 is 80. So therefore D is the square root of 80. Okay, and what is the square root of 80? I don't think it's 5 plus 3 root 5. So let's see if we made a mistake somewhere. Okay, so square root of 80 can be broken up into, let's do 8 times 10, but then 10 is 5 times 2. So we have 16 times 5. There's the perfect square I'm looking for. So that's 4 root 5. Okay, so 4 root 5. Okay, guys, there's the mistake. Okay, so we weren't too far off. For this equation here, r squared is 5, so the radius is root 5, so that should be root 5 there. Okay, so this should be root 5. So 1 root 5 times plus 3 root 5 is 4 root 5, and that's exactly what we had here. Okay, just one little mistake like that can cost the whole question. So just make sure whenever you're doing your algebraic steps, you're just keeping track of everything very carefully. Okay, so what have we shown here? We've shown that the distance between the two center points O and C is 4 root 5, and we've shown that the sum of the radius, radii lines from the red circle and the blue circle when added together also give you 4 root 5. In conclusion, that means that the distance between the centers is the same as the sum of the radius lines, which implies that the circles only touch at one common point. Okay, and that's how we would do this type of question. I'll see you in the next one.